Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on exercise 8D, so differentiating vectors, and we're looking at question 5. Okay, so I'm given the mass of a particle, and I'm given its position vector. Okay, and I want the speed. So I don't need the mass just yet. If I want speed and I'm given a position vector, I basically just want to differentiate the position vector. So let's crack on with that. So we're doing question 5. Okay, so I'm differentiating this. So V is R differentiated with respect to time. So T cubed is going to differentiate to 3T squared, and minus 12T is going to differentiate to minus 12. And then for the J coefficient, 4T squared is going to differentiate to 8T. And minus 6T is going to differentiate to minus 6. Okay, so there's the velocity. But they want the speed. And so to find the speed, and they're not saying in terms of T, so I clearly need a value for this. So let's have a think about what they mean. So the speed of projection, so that's the point at which it is projected. So that's when T is 0. So got to be sort of careful to interpret that and think about what they're saying. So when T is 0, the velocity, well, that's going to be minus 12. That's going to be minus 6. Okay, so that's the velocity when T is 0. And the speed is going to be the magnitude of that. And I'm not bothered as I'm squaring. I'm not really bothered about those negatives. So that is going to be 6 root 5 or 13.4 meters per second. Okay, let's just double check that answer. Yes, they've left it at 6 root 5. So that's not so bad. When you compare that working to the fact that's worth 5 marks, there's not a lot of working, and none of it was particularly tricky, but it's the interpretation. So things like realizing what they mean when they say the speed of projection, they mean at the point at which it was projected. That's kind of where the marks come in. It's for the thought process, not the actual calculations. Okay, so find the value of T at the instant when P is moving parallel to J. Okay, all right, so if something's moving parallel to J, it's moving straight upwards. Okay, so your I vector is to the left and your J vector is straight up. So if it's moving parallel to J, it's moving straight upwards. Okay, and if we're after anything to do with how it's moving, then that's going to be to do with its velocity. And if it's moving straight upwards, then the I component of the velocity must equal 0. Okay, so if it's moving straight up, it's not moving left or right at all, the I component of the velocity must be 0. So that's the I component of my velocity, and that, so the coefficient of that must equal 0. Okay, so just to really quickly run through that again. So if it's moving parallel to J, it's moving straight up. So it's not moving left or right at all. So if it's not moving left or right at all, its I component has to be 0. So that's what I'm currently solving. So 3t squared is 12. So t is 4. So t squared is 4. So t is, I'll put plus or minus 2 just to show my working, but obviously it's a time, so it can't be minus 2, so t is 2 seconds. Okay, so again, not a hard calculation, it's the interpretation that's the tricky bit. Okay, so the position vector of P at the instant when P is moving parallel to J. Okay, well, so to be honest, if you've answered part B, this really is not bad at all. So I'm going to go back to my position vector and just substitute T is 2 into this. So if T is 2, that's going to be 8 minus 24. So minus 16. And if T is 2, that is going to be 16 minus 12. Okay. And yeah, I don't think there's any tricks there. Let's just check that my mental arithmetic is okay. Yeah, we're good. Okay. Right, and then Yes, actually, that's pretty nice for 4 marks, sorry, for 3 marks there. Okay, so D, given that the mass, yes, so they weren't going to tell us the mass for no reason. So given that the mass is 0.5 kilograms, find the magnitude of the force. So that's going to be F equals ma. Okay, so 4 marks available for this one. So I need the acceleration, and the acceleration is going to be velocity differentiated. Just about, okay, so let's stop being lazy and write the velocity out again. So the velocity was 3t squared minus 12. So we already had this for part A. And 8t minus 6. Okay, so that's I'm going to get mini marks for this part of the question because I already had that. Acceleration is going to be the differential of that. So 6t, and then the minus 12 is going to differentiate to nothing. 8t is going to differentiate to 8, and the minus 6 will differentiate to nothing. So that's the acceleration. I could find the force in terms of t, but I'm going to, and that would work fine. I'm going to sub in t is 5 and get the actual specific acceleration at that point. So when t is 5, that's going to be 30i plus 8j. And then I'm going to use F equals ma, and F and A are both vectors, but m is a scalar, so that's fine. I can multiply, so the mass was 0.5. Okay, so that's the mass times the acceleration. Let's rid of that. Okay, so that's fine. So I'm just going to multiply each of those components through by a half. So that is the force as a vector. They want the magnitude, so I'm not going to lose that easy mark because the magnitude of F is just going to be Pythagoras. Okay, so 15 squared plus 4 squared, root answer. So root 241 in exact form, or I can give it to 3 significant figures because it didn't specify. And yeah, it didn't specify how to do it, so let's just double check our answers. Yeah, I think we're good.